everyone, I'm Leah, and we will talk about continuity of a function. So first, what is continuity? A function is continuous at a point if its graph has no breaks, gaps, or jumps at that point. To say that a function f of x is continuous at x equals a if these three conditions are met. First, the f of c is defined. This means there is a specific value for f of c. Second, the limit of x as x approaches to c exists. This means as x gets closer and closer to c from both sides, the function approaches a same value. Third, the limit of f of x as x approaches to c is equal to f of c. This means the value of function approaches as x gets closer to c is the same as the value of the function at c. So here are the example to know if we can apply those three conditions. So determine if the given function is continuous at the indicated number c. F of x equals x if x is less than or equal than 1, and 3x minus 2 if x is greater than 1. So first, let's input the given. So let's go back to the three condition. The f of c is defined. So para makuha nato si f of c, we need to look the equal sign in the given. So here are the equal sign. F of x is equal to x if x is less than or equal than 1. So our f of x is x, f of 1 is equal to x, so equal 1. So our f of c is defined and equal to 1. So let's proceed to step 2. The limit f of x as x approaches to c exists. So there are two limits, the right hand limit and the left hand limit. So first, the left hand limit. Left hand limit. So our x is approaches to 1 to the left. This means that our x is less than 1. So our f of x is x, which means equals to 1. So let's proceed to right hand limit. So our x is approaches to 1 to the right, which means our x is greater than 1. So let's find here. So our f of x is 3x minus 2 if x is greater than 1. F of x is 3x minus 2. So 3, and our x is 1, which is here. Let's input x 1 minus 2 is equal to 1. So 3 times 1 minus 2 is equal to 1. So our limit is exists and equal. So let's proceed to step 3. The limit f of x as x approaches to c is equal to f of c. So here, our limit is equal to 1, and our f of c is equal to 1 also. Therefore, the function is continuous. So if any of these conditions are missing, the function is discontinuous. So what is discontinuity? A function is discontinuous at x is equal to c if there's a break, gap, or jump at that point. So there are two main types of discontinuities. First, removable discontinuity, and second, essential discontinuity. So what is removable discontinuity? A removable discontinuity is a type of discontinuity in a function where there is a hole in the graph at a certain point, but the function can be made continuous by redefining that point. A function f of x has a removable discontinuity at x equals c if the limit exists. Second, the function value f of c is either missing or not equal to the limit. So let's try this example. Determine if the given function is continuous at indicated number c. If it is discontinuous at c, determine if the discontinuity is removable or essential. If it is removable, redefine the function to make it into a continuous function. So here, f of x is equal to 2x minus 1 if x is less than 1, and 2 if x is equal than 1, and x if x is greater than 1. So first step, let's define f of c. So as I said earlier, to define our f of c, we need to look the equal sign in the given. So our x, f of c is equal to 2. So our f of c is 1, I mean 2, and define. So let's proceed to step 2. The limit exists. Limit f of x as x approaches to c, ln lim f of x as x approaches to 1 to the left. As x approaches 1 to the left, our x is less than 1. So our f of x is 2x minus 1. So let's input the x. 2 times 1 minus 1 is equal to 2 times 1 minus 1 is equal to 1. And for the right hand limit f of x as x approaches to 1 to the right. So our x is approaches to 1 to the right, which means our x is greater than 1. So our f of x is x equals 1. So our limit exists, and the right hand and left hand limits are equal. So let's proceed to step 3. The limit f of x as x approaches to c is equal to f of c. Our limit f of x as x approaches to c is 1, while our f of c is 2. So that means our limit f of x as x approaches to c are not equal to f of c. Therefore, the function of f of x is discontinuous, and it's removable. Since our discontinuous is removable, we can make it continuous by redefining the point or the f of c. If we redefine f1 equals 1, then it becomes continuous. So let's proceed to essential discontinuity. An essential discontinuity is a type of discontinuity where a function has a jump or an undefined behavior at certain point. We cannot fix it by simply redefining the function at that point. A function f of x has an essential discontinuity at x equals c if the limit does not exist, because the right hand limit and the left hand limit are different. So let's try. Here are the example. F of x is equal to 3 plus x if x is greater or equal than 1. And then 3 minus x if x is less than 1. So first step, we need to define our f of c, which is f of c f1. Let's find the equal sign. 3 plus x. Substitute the x. 3 plus 1 is equal to 3 plus 1, 4. So our f of c is defined and equal to 4. Proceed to step 2. Limit of f of x as x approaches to c. The left hand limit f of x as x approaches to 1 to the left. Since our x is approaching to 1 to the left, so our f of x is 3 minus x. So let's input 3x. 3 minus 1 is equal to 2. And the right hand limit as x approaches to 1 to the right, 3 plus x. Since our x is approaching 1 to the right, x is greater than 1. So our f of x is 3 plus x. So let's input our x. 3 plus 1 is equal to 4. Our limit exists, but the right hand limit and the left hand limit are not equal. So therefore, the function of f of x is discontinuous and it's essential. Since our discontinuous is essential, we cannot fix it by simply redefining the function at that point. That's it for this tutorial. I hope this helped you understand continuity, discontinuity, and how to determine the type of discontinuity in a function. Keep practicing because practice leads to progress. Bye!